3.
Welcome from VIT Chennai University. So we are doing a self detection. I'm Roshni and my team is Swati and Roshni. So now we're gonna explain about the project. So first let's discuss about the introduction. Introduction. So, the lungs are a pair of sponge-like cone-shaped organs. The right lung has three lobes and is larger than the left lung, which has two lobes. Lung tissues transports oxygen to the bloodstream to go to the rest of the body. Cells release carbon dioxide as they use oxygen. Next, how the lung cancer is the one of the most serious and widespread disease that is responsible for very large number of deaths every year. Among all different types of cancer, lung cancer is the most prevalent cancer, having the highest mortality rate. Next, this is the data set we have used. So we took this data set from the Kaggle. And next, so we're gonna use so this is about the dataset info. So this dataset contains three chest scan types, which are adenocornea, large cell acronema, squamous cell cornema, and one folder for the normal cell. Data folder is the main folder that contains all step folders inside data folder are test, train, valid. This test data represents testing set and train data represent training set and valid data represent validation set. And the percentage of the training set is 70% and the testing set is 20% and the validation set is 10%. So next, we're gonna go objective. So what is the main objective of this project is that to classify the given CT scan using image as adenocornema and large cell and cornema and squamous cell cornema and the type of cancer or normal by various using deep learning tech. So we're gonna predict how the cancer is present. So these are the deep learning models we're gonna use. The first one is CNN, and next one is VGG16, and third one is Inception V3, and fourth one is ResNet 50. So, thank you. Next, Swati is gonna explain about the code, how we implemented.
Here is the implementation part of our project. So we downloaded the data set from Kaggle. So it is downloaded as a zip file in our computer. So we import it to the Google Drive. So Google Drive. So we are mounting the Google Drive here, and it is imported as zip file. So we have to unzip the thing. Then we have to download some important libraries from Keras. We are using VGG16, ResNet, everything. So we are importing it here first. Then we are going to load the train data set. So here is the code to load train data set. So we found 613 images belonging to 4 class. That 4 class is like adenocarcinoma, large cell carcinoma, normal, without cancer, though squamous cell carcinoma. Then again, we are done with training data. So we are going with validation data now. Again, we are downloading the validation data here, and it is showing that found 72 images belonging to 4 classes. That is, we have 72 images in validation data set, and that 4 classes are, as I already said, 4 types of cancer. Next, we are loading test data set. Here, this code is to load test data set. So we found 315 images belonging to 4 classes respectively. Then we are implementing our deep learning models here. So our first deep learning model is convolutional neural networks, that is CNN. Here we gave the activation layer as ReLU, kernel size as 3 into 3, input shape is like 350 into 350 into 3. So here we have Adam optimizer, binary cross entropy. Then it's showing the model summary of that particular CNN model, and it has shown the total parameters, trainable parameters, and non-trainable parameters is 0. So we are showing the fitting of the model. So here is a code, and we have run 5 epochs for this. Then we are going to check the accuracy of the model. So what is accuracy of the model? The loaded for this data set is 25%. Okay, then what we are plotting the data accuracy of the particular model. So model accuracy is like 0.25%. So this is a model loss. So it is this orange line is epoch and this blue line is loss. So as CNN model shows 25% accuracy only, we are next moving with VGG16 model. So basically here, this is the code to download VGG16 model. And we are doing it from the Keras only. So we have the code thing there itself. So we are loading. And here we have like optimizer as Adam and loss as like categorical cross entropy, and it's showing the model summary. Again, the total parameters, trainable parameters and non-trainable parameters. Then we are fitting our model here, and epochs could be like more than 12 or anything, but as time consumption we have given epoch as 5, and we are checking what is the accuracy of the model. Then the accuracy of VGG16 shown here is 56%, which is better than CNN model. So we are proceeding with the next model, and here again is the graph for the model. This is model accuracy and model loss. Then as this model, I mean VGG16 also shows only 56% accuracy. We are proceeding with another deep learning model. So what is that model? So this is Inception V3 model. So basically we have to load the same from TensorFlow. Then we are loading, okay, activation layer is ReLU, and we have given softmax for the second layer. So loss is categorical cross entropy. Metrics is accuracy. Okay. Then we have fitting the model. Again, we have given epoch as 5, and the model summary is shown here. And the accuracy of the model now has improved. It is 67%. It is better than VGG16, right? Next, again, same, we are plotting the graph for Inception V3 model. Okay, we are not satisfied with accuracy of the deep learning model. So we are again proceeding with one better model, which is ResNet 50 model. So again, image, we are giving image size as 350 into 350 into 3, and we are max pooling the thing. Then again, activation layer as softmax, optimizer as Adam, loss as categorical cross entropy, and we are building the checkpoint for this thing, and we are fitting the model. And again, epoch is 5. Then we are generating the accuracy of the model. Now with 70.4%, and this is better than the previous model. So again, we are plotting the graph for this model also. Okay, we are done with the models, I guess. Yeah, we are going with a comparison of the model. So let's this code is for comparison of the models, which accuracy is higher, which accuracy is lower. So we started with CNN, it showed only 25%. VGG, it showed around 60. Inception V3, it shows around 65. And ResNet 50, it shows around 80. So basically, ResNet 50 is the better model for predicting the lung cancer. Okay, then we are going to do the important part, like we are going to predict whether this image belongs to which part of this cancer. So we are going to copy the path of any one of the image from the data set, and we are going to paste here, and it will show as which type it belongs to. Basically, this path of the image is like it belongs to large cell carcinoma. If we paste the image which belongs to adenocarcinoma, it will show as adenocarcinoma. If we paste the path of the normal image, it will show as normal. So that's it. This is our project. We are finally done with the prediction of the lung cancer.
Here is the final conclusion of a video. In conclusion, deep learning models such as CNN, VGG16, Inception V3 and ResNet can be used to predict lung cancer. Among these models, ResNet 50 has shown the best accuracy of 70%. These models have the potential to improve the accuracy and speed of lung cancer diagnosis and treatment, but further research is needed to improve their performance and capability in clinical settings. This work presents a first step towards automating the classification procedure and eventually becoming better than trained technicians at this particularly crucial and critical task. The early discovery of lung malignancy is a confront because of the structure of tumor cells, where the greater numerous strategies to distinguish the lung tumor in its beginning periods. The manual examination of the samples is tedious, inaccurate, and requires intensive trained person to eliminate diagnostic errors. Future work. Lung cancer detection can be further classified with the stages from the detected cell tissues. Staging of lung cancer helps decide which therapy or therapies should be used. Lung cancer staging tells how much cancer has spread. Knowing the stage of cancer helps the healthcare team know the risk versus the benefits of different procedures and treatment. Here are the references from where we have taken this research from. Thank you guys. Had an amazing time with you. See you again in next video. Thank you.